G'day guys, we've got an integration question for you today where we're going to have to integrate this rational function here. We've got x minus 8 over x plus 2, x minus 3. Now before we integrate this, what we're going to do is we're going to split the rational function into two partial fractions that take the form a over x plus 2 and b over x minus 3. And to start with, what we're going to have to do is we're going to have to figure out what a and b are so we can split this function into two smaller fractions. Okay, so the way that I would go about solving this is I'm going to combine the two partial fractions and then work backwards. Now I'll show you what I mean by that. So to start with, I'm going to get both denominators in each of these partial fractions to look like the original denominator. So in this case, we've got a over x plus 2 and we've also got x minus 3 to make it look the same. So we don't change the fraction, we're going to just put x minus 3 at the top. So then it's basically just been multiplied by 1. We're going to add to it b. Now this is over x minus 3. And I'm going to use the same strategy as I used with the first one. I'm going to put x plus 2 there. And then I'm going to have x plus 2 in the top. Now, what I can do is, because I've got the same denominators, I can then add the numerators together. And what I'm going to do is I'm going to do two steps in one hit. I'm going to multiply out the brackets and add the numerators. So I'm going to have ax minus 3a plus bx plus 2b, all divided by x plus 2 x minus 3. Great. So what I'm going to do from here is you can see that the denominators now look exactly the same in this rational function and the original rational function. So now we just have to get the numerators to look the same. So let's just make this equal to x minus 8 over, what have we got here, x plus 2 x minus 3. Okay, so from here, we don't have to work on the denominator anymore at all. So what we're going to do is we're going to join together our like terms. So here we've got ax plus bx. So let's go down to the next line. We've got ax plus bx. Then we've got minus 3a plus 2b equals x minus 8. Cool. So we can then factorize these x's. So we can have x outside of a plus b minus 3a plus 2b equals x minus 8. Cool. Now what we can see here is the numerator out the front of the x here is 1. So here we have a coefficient of 1 for x on the right hand side of the equality. So therefore, to make the coefficient in front of the x on the left hand side 1, a plus b has to equal 1. So we can also write that as b equals 1 minus a. Now why am I doing that? Well, what we can also see, let's just change colour. On the other part of the equation, we've got 2b minus 3a equals negative 8. because we know that b equals 1 minus a, we can stick that in. We can then go, well, this is going to be 2 minus 2a minus 3a equals negative 8. We're going to have negative 5a equals negative 10. A equals 2. So therefore, if negative 5a equals negative 10, a equals 2, and b is going to have to equal negative 1, because b is 1 minus 2. Cool. So what we can then do is we can express, so therefore we can say that x minus 8 divided by x plus 2, x minus 3 is equal to 2 over x plus 2 minus 1 over x take 3. Now those brackets are unnecessary, I'm just doing that for my own benefit. Okay, so there's the answer for part A. Now on to part B. The reason that it asks you to split this rational function into its partial fractions is because it makes the integral a hell of a lot easier. Because what we're going to be able to do is we're going to say the integral of this is going to equal the integral of 2 over x plus 2 dx minus the integral of 1 over x take 3 dx. So hopefully you guys are aware that the integral of 1 over x is equal to the logarithm of x. So this turns into quite a simple part of the question. The integral of this is going to be 2 log of x plus 2 minus the integral of this is 1 log, but you don't have to put the 1 in, is minus the logarithm of x take 3 plus c. So you can see that by breaking up this quite large rational function into its partial fractions, taking the logarithm is quite easy. The hard part to start with was actually making the partial fractions, but once you've done that, the second 3 marks is quite easy to get. So what we did is we built the fractions back. Well, we built. That's a silly way to say it. What we did is we put the partial fractions back together as one fraction, so we could express the function with the same denominator as the original function. Then what we did is we made the two numerators equal to each other and then solved for a and b. Once we split the rational function, we then were able to integrate it quite easily. So if you're having trouble with the actual integration, I've got other videos on basic integration, but this one here was mainly focused on breaking up the partial fraction that you saw in part A. So I hope the video helped, guys. If it did, swing it a like, subscribe to my channel. I put out new videos all the time on maths and other things. But until next time, guys, I'll see you later.